Welcome to a little bit of Cisco Lab Rat fun, playing in the lab, networking with fish. Today we're going to go ahead and play a little bit with some IWAN stuff, specifically a little bit of DMVPN, and a little bit about PfR V3, do a little bit of impairment on a link, see if the PfR V3 Intelligent WAN magic. So what we have in front of us is we have three branches. We have branch 1 that has two routers on it, both of them are 4321s. The top hockey puck router is Branch1 Router 1. That is connected to the MPLS cloud. Branch1 Router 2 is connected to the internet cloud. And since I live in a lab environment, I can go ahead and have the addressing be that everything that's at branch 1 is 10.1/16. Similarly, branch 2 is one router there. It's also a 4300. But that actually has two links off of that one router. One link to the MPLS, one link to the internet. And again, the addressing is 10.2/16. Branch 3 is a 4451, and it also is one router at the branch, one leg in the MPLS, the other link over in the internet, and again, addressing can be very simple, 10.3/16. Up at the hub site, everything at the hub site is 172.16.0.0/16, so 172.16/16 is anything at the hub site. What we have is connected to the MPLS cloud. We have an ASR 1002X, which is acting as the DMVPN hub for Tunnel 1. Now, when I say Tunnel 1, it is not imperative that all of the branches, it's not necessary at all, that all of the branches actually have their MPLS connection be on a tunnel interface called Tunnel 1. However, I am of the belief that I would like to design my network and begin with the end in mind. And beginning with the end in mind, I would like to go ahead and have a network where I have some consistency and things have meaning. So I do what Russ White told me to do, which was you configure with intent. You have your configurations show you what your intent is. My intent is that everything that is Tunnel 1 is on the MPLS cloud. And it is in the range of 10.0.224.0/24, where my DMVPN head end is .1. Then the router below that, connected to the internet, is my DMVPN internet hub, which is Tunnel 2 on that ASR 1002, so it's DMVPN Tunnel 2, 10.0.232.0/24 for the mGRE, for the subnet, for everyone connected to that DMVPN tunnel, and .1 again for my IWAN hub. Now what we're going to do is we're going to go ahead and focus on branch 1 and branch 3. So if you look at branch 1 right now, you'll see that if you look up at branch 1 up at the phone, I have an IP address up there from a DHCP binding that I got, 10.1.101.104 for that phone. If you look at the phone over in branch 3, I have 10.3.101.101. We're going to go ahead and I actually have a phone call going up, voice and video, between those two Cisco phones. Now let's go ahead and go over to LiveAction and see a little bit about this. Now, if you actually notice right here, this is my phone call only. I have taken LiveAction and I have gone from the default of please show me all of the traffic that's going on in my little lab environment network, which is just a little lab environment network, but it's still all of this. And I have said, you know what? I'm going to go ahead and I'm going to ask you to just drill down into anything that has an AF41 in it. So if it has an AF41 in it, that is my video that is on this phone call. So as we can see, this is branch 1. We have the phone going into branch 1 router 1. It's branch 1 router 1 because that is my HSRP primary to get out of the branch for that subnet. And I'm going out to the MPLS cloud, and this is actually telling me, LiveAction is actually telling me I am not going up to the head end. I am not going up to the head end of this tunnel. I'm actually going out to the MPLS cloud, and from the MPLS cloud, I am not bothering the ASR 1002X. I am not bothering the DMVPN head end of this. I am actually going into the MPLS cloud, going out of the MPLS cloud, and I'm going directly to branch 3. And this is actually going in the other way as well. So that's very interesting. So what actually happens is there's a DMVPN tunnel here, and what I have done is I have put a config in up on the head end tunnel, which actually says, you know what, I want you to be able to do NHRP redirects. I have also gone ahead and on the tunnels, on the branches, said, you know what, I want you to install NHRP shortcuts. So let's see what that looks like. So if we go over here to branch 1 and we do a show ver, we will see that this is actually a 4321, and we're running what I internally call 3.14. And so we're running that, and if we do a show run interface tunnel 1, this is our DMVPN tunnel. In the IWAN model, actually a lot of this is very prescriptive. You can actually go ahead and do this on all the branches. In fact, all of my branches look just like this, except that the fourth octet for tunnel 1 is different. I actually didn't put this in, LiveAction put this in. So this is different, and this is different, and I could, I guess, change the bandwidth, but everything else is the same. So it's a very templatable deployment. So what is the config on here? So it's IP NHRP shortcut. That IP NHRP shortcut says that I would like to install shortcuts so I do not have to go up to the hub via the tunnel from branch 1 to the hub and then back out the tunnel to go to branch 3. Now how do I configure that up here on the head end? And it is right there, IP NHRP redirect. Now, if you actually use Prime, for example, 2.2, and you look at the templates, the CVD templates for DMVPN are in there. Again, this is a very typical hub template, and it's pretty much cookie cutter from your perspective as far as what you put in here. So I'm going to go ahead and go back in here. So that means that I'm supposed to install shortcuts. So if we do a show IP route, what we're actually doing, and this is very much your decision, what we're doing is we're not actually disabling a split horizon up on the hub. What we're doing is we know we're going to go ahead and go to the hub in the beginning to get the redirect. So we're just going to go ahead and go to the hub. So we have the hub actually send us, sorry about that, just a 10/8, which means the hub is sending, you know what, I can get you to anything in the 10 network. I can get you to 10.2, I can get you to 10.3, I can get you to 10.4, I can get you to whatever it is that you want to get to. So you'll notice that I actually have no control plane, no EIGRP for 10.316 over here. So again, from that perspective, that's what we chose to do in our lab environment. Now, if you look down here, we are branch 1, which is 10.1, and we are talking to, we have an active phone call conversation going on with 10.3.101, which is right here. And it has a little H in it. And the H means it's NHRP. You'll also notice that the administrative distance is actually 250. Because this was actually installed via NHRP via a redirect with the NHRP DMVPN hub that told us, you know, if you want to go ahead and get to this, just go ahead and go over here. So we can actually do a show IP route, next hop override 10.3.101.0, and it'll say, okay, you know what, if you want to go ahead and get there, just go directly to it. So you can do a show IP NHRP shortcut, which says, okay, look, if you want to get to 10.3.101, which is on this tunnel, you're going to go ahead and you're going to go to the NBMA address 11.11.13.102. So what is that address? That address is right here. It is right here on this branch, which is beautiful because I can go ahead and go right to a directly attached connection to the MPLS service provider. And because I'm doing crypto, I will also go ahead, so if we do a show DMVPN, you'll see that I am actually talking with, and so 30 is actually branch 3. So I'm actually talking with branch 3 right here. And if you look at the DT1, this is dynamic, and the route is installed, and I have a shortcut. And that's the reason why this is happening. We do not have to go up to the DMVPN head end. Now, the default behavior with DMVPN is to not have those two commands in. So if for regulatory reasons or whatever reasons you want to force your spokes to actually go up to the hub before you hairpin back out, that's going to be the default. If you want to go ahead and allow them to do shortcuts, you do the IP NHRP redirects up at the DMVPN head end, and you do the IP NHRP shortcut down at the spokes, which is what we have in our environment. We're allowing the spokes to actually talk. Now, let me ask you a question. What if, so we know that it's going this way, this is what LiveAction is telling us. What if I were to cause impairment? Now, obviously, if Branch 1 Router 1 out and out lost its MPLS link, routing would tell us to go ahead and go via Branch 1 Router 2, because Branch 1 Router 1 would have lost its information on how to get over there. But what if I do 2% loss? I have a WAN bridge, which you can actually download from the internet. It's an OVA, and you can go ahead and put it in line, and you can cause loss. So what if there is 2% loss here, more of a brownout type environment as opposed to complete loss? So what we can do is we can now go ahead and introduce the intelligent path control portion of IWAN, which you have this master controller. You have a master controller, a domain master controller. These 3 branches and the hub site are all in the same domain. I call it domain default. And so we have a domain master controller at 172.16.0.3. So let's go ahead and look over at that. So if we go over to the domain master controller at 172.16.0.3, the first thing that's kind of cool about this is actually a CSR 1000V. So this is iOS XE on a VM. So it's an CSR 1000V, and it's my master controller, because the master controller is really more of a control plane brain. So if I do a show run and then section domain, this is the policies that I have that I want to push out to everyone in this domain. Now, I'm not going to specifically teach you IWAN here. What I'm going to do is just give you a little taste of a little bit of this stuff. Keep it simple, keep it short. So I'm not going to get into all of this, but I am the master at the hub site. I am the domain master. My IP address is 172.16.0.3. And we have a voice phone call which has EF in it, and it has AF41. So it has a voice video phone call. The voice is going over EF. The video is going over AF41. My policy for this from a intelligent path control perspective is to prefer the MPLS link. And if there is an impairment on that link that crosses what I have defined as a threshold crossing event, then it is going to go ahead and fall over to the internet. So I have actually gone with the Cisco IWAN CVD thresholds. So I actually I have not overridden those thresholds. So let's go ahead and do a show domain default master policy. Now, a couple things that you'll notice about this. First, the first thing you'll notice is that I have no policy published pending. No policy published pending at all. which means that I have already pushed out to all of the boarders and everybody else what the policies are in our PfR V3 domain. Class voice, now you already saw class voice was match DSCP-EF and make it policy voice. So did you notice this? No, this was not in there. This was not something that I had to configure the PfR master controller with. This is actually already in the Cisco CVD for the IWAN. If you look at the CVD for the IWAN for the January 2015, you'll notice I believe it's on page 182. I'd love to go grab my book right now, but it's over there, which actually already has in it, these are what we recommend. So you can go ahead and say, you know what, this is voice. So since it's voice, these are the CVD thresholds that are already there when you say voice. When you say real-time video, these are already the thresholds there as well. If you use the word low latency, these are the thresholds. If you use the word bulk data, these are the thresholds. Again, all in the CVD. So let's go ahead, and there was no publishing pending, so if we go over to Branch1 Router 1 and we do a show run section domain, and for those of you who have ever played with OER or PfR version 2, this is not that. This is really, really simple. Branch1 Router 1, it just says, okay, I am the master for this site, so I am the branch master. I am the master for this branch, and I am also a boarder. Any PfR device that sits on one of the two ends of a DMVPN tunnel is the boarder. So I want you to hear, when you hear boarder, I want you to hear forwarding of traffic, classification of traffic. When you hear master, I want you to hear control plane. So every site, branch 1, will go ahead and it will actually have, so branch 1 has Branch1 Router 1, which has a DMVPN tunnel to over the MPLS, and Branch1 Router 2. So that means since there are two routers there that are both at the ends of a DMVPN tunnel, Branch 1 has two boarders, one in Branch1 Router 1, one in Branch1 Router 2. Branch 1 is also a site. So as a site, it has a master there. We have made the master Branch1 Router 1. And if we look back here, it is this branch master that talks back to 172.16.0.3. So we can actually look here, show domain, default master policy. And we can see that if we run this, we have the same policies here as we did over on the domain master. Now, let's go ahead and actually get rid of this one. So let's go over to the domain master, do a show run, just up arrow, we'll cheat, we'll do an up arrow. And I'm gonna go ahead and do a config T, and I'm gonna go ahead and I'm gonna get rid of no class your app. So it's been deleted, so if we look, it's gone. And now if we go ahead and repeat and do the show domain default master policy, we will see that we have a publish pending in 1 second. And the publish that we have pending is for that thing to be gone. So now we can go ahead and see that there is no publishing pending. So I should be able to go over to Branch1 Router 1, where we saw the last time we did this. This was in there. We're gonna up arrow, and we're gonna see that it's gone. So again, we actually have the policies for your intelligent path control in one specific location up at the domain master. So now what do we do with this? We have policies, but how does that help us with the 2%? So let's go ahead and look. And we're going to look at the traffic classes. So what we actually have is we actually have our phone call here. It has already been classified. So we have the 10.3.101.0, which is the destination site prefix, and we've got the DSCP value as EF, so that should be adhering to our voice policy. And then we have the video part of the voice video phone call, which is AF41, which should be adhering to our video part of our call. We have CN, which means that we are told that we're supposed to control it, so we have identified it, we have classified it. It is a traffic class that we're supposed to take care of, and we have it on service provider MPLS. And we have a primary channel, and check that out. We have a backup channel. We have a backup channel that is already ready to go. So let's go ahead and look at the video. So if we look at the video, it is controlled traffic, it is in policy. So we are on an MPLS link that is in policy. We've been on the link for 5 minutes and 26 seconds because I've played a little bit. We were on INET before. We'll go ahead and do that again. We are coming out of Tunnel 1. We know that since Tunnel 1 is actually MPLS everywhere, we're going out the MPLS link, which means we're going out of Router 1, Branch 1, and we have a backup channel that is already going. It is backup channel 42, and if we go over to Branch 1, Router 2, and let's do is it backup channel 42? So the present channel is a 41, backup channel is a 42. So let's go ahead and do this. Let's do a begin, channel ID 42. Now what you'll notice is I am over on Branch 1 Router 2 because our backup channel for impairment of the MPLS link is, interestingly enough, on Branch 1 in another router, which is the reason why I picked this one. It's a lot easier if we were going to do this on Branch 3 because it's one router. So Branch 1 Router 2 is actually configured to be a border, and the master that it is talking to is the site master. So it is Branch 1 Router 1. Now before I up arrow again and look at the channel ID, I want you to see that we actually have at the end here, it's 16846. Ready? And now it's 17964. So what does that mean that we're doing? What that means that we're doing is over here, Branch 1 Router 2 has been instructed by the site master to be probing over on the internet for this backup channel traffic class, both for the EF and for AF41, which means that Branch 1 Router 2 is sending probes. It's sending PfR V3 probes over to the other border, which is Branch 3 Router 1. It is sending two types. It is sending one with EF markings to see and probe the health, delay, jitter, loss for the EF traffic class. It is also doing it for AF41. And it is checking the health of that because, of course, what we don't want to do is get 2% loss on the MPLS, only to then move it over to something that has 3% loss. So we're going to probe in advance. So what we're going to go ahead and do is we're going to go back over here, and what I'm going to do is I'm going to go ahead and I have a video recording going on that I'm going to use my iPhone and actually record myself waving at the phone so that we can actually see the blip. It is going to be almost imperceptible. So what you're going to need to do is to look for like a flash or slight pixelation or slight color change. And I'm sorry, but that's the event because we already have this backup channel going and it is that fast. So as we can see right now, AF41, we're going over the MPLS. We are going out Router 1 in Branch 1, out Tunnel 1, which brings us on the MPLS. What I'm going to go ahead and do is you'll notice on the diagram we have these little things called WBs. These are our WAN bridge. Again, you can get an OVA, you can actually put it in. The only gotcha is that when you put it in, it doesn't like a delay of 0, so you have to put a delay of 1 in. Now, should a delay of 1 cause us any problems? So if we go ahead and come back here and say master policy, no, it shouldn't, because our delay threshold is actually 150 for voice and 150 for video. So what we're going to do is we're over on the MPLS. I am going to come over to here, and I am going to go into this VM. Up at the top, you'll see it says WAN bridge, bridge 1 router 1 to PE. So I'm going to go ahead and come in here, and I'm going to do custom. My bandwidth here between Branch1 Router 1 and the MPLS cloud is, oh, that's not good. Let's try that again. So nothing. Let's try that again. So custom 1500 1, and we're going to do 2% loss. Okay, and we're going to go ahead and make sure before I hit enter there that we're still good over here and I didn't just mess that up. So we're still on the MPLS and our backup is still channel 42. So I'm going to go ahead and come over here, and I'm going to hit enter, but I am going to record myself waving my hand. So I'm waving, and now I'm going to come over here, and I'm going to hit loss, and I'm waving, and I hate to tell you this, but I think nothing really exciting happened. And we're over on the internet, so I don't even think I saw it. So now we're over on the internet. And so our primary channel is 42, and our backup channel is now 41. So we're actually going out branch 1 router 2 on tunnel 2. And this is the reason why I would suggest that you make it deterministic. I mean, branch 1 router 2 is in a separate box. You could have made it tunnel 1 also. But personally, I think it's really easy to go ahead and go down here and see internet, MPLS, internet. My personal opinion. And so that's it. And now we're actually sending the traffic over. So let's go over to LiveAction and see what it sees. And let's go ahead and do a refresh. Click mouse to gain control. Refresh. LiveAction, tell me what I'm doing now. And what I am doing now is I am going over the internet and I am off the MPLS. And that is how you handle a brownout with a backup circuit already in place and probing on the backup link. And I hope you had fun in the lab with me. Have a great day.